Welcome, ladies and gentlemen, to the final part. I'll be covering chapters 10 to 13. That's approximately 90 slides. I'll try to do this as fast as I can. Please feel free to double the video as you please. So let's begin. Chapter 10, Reviewing Implementing Subprograms. The generic semantics of call and return, implementing symbol subprograms, implementing subprograms with uh, stack dynamic local variables, nested subprograms, blocks, implementing dynamic scoping, subprograms, required storage, status information of the caller, parameters, return address, functional value. Subprograms consist of two parts: subprogram code, subprogram data. The format is called an activation record. An activation record instance, an ARI, is a concrete example of an activation record. Typical activation records for language with stack dynamic local variables. The stack moves up, it goes return address, dynamic link, parameters, local variables. Implementing subprograms with stack dynamic local variables. The activation record format is static, but its size may be dynamic. The dynamic link points to the top of an instance of an activation record of the caller. An activation record instance is dynamically created when the subprogram is called. Activation records instance resides on runtime stack. The environment pointer EP must be maintained by a runtime system. It always points at the base of the activation record. Revise semantic call and return actions. Caller actions creates an activation record instance, saves the execution status of the current program unit, computes and pass the parameters, pass the return address to the call, transfers control to the call. Program actions of the caller, saves the old EP in the stack as a dynamic link and creates a new value, allocates local variables. Revise semantic calls and return actions, epilogue actions of the call. If there is a pass by value results, if the subprogram is a function, the value is moved to the place accessible to the caller. Restores the execution status of the caller, transfers back control to the caller. It restores the stack pointer by setting the value of the current EP minus 1 to the set of the EP to the old dynamic link. Dynamic chain and local offset. The collection of dynamic links in the stack of a given time is called a dynamic chain or a call chain. Local variables can be accessed by their offset from the beginning of their activation records. Recursion adds possibilities of multiple simultaneous activations of a subprogram. Each activation requires its own copy of a formal parameter and dynamically allocated local variables along with the return address. Nested subprograms are the process of allocating non-local reference. Find the correct activation record instance. Determine the correct offset within the activation record instance. Nested subprograms. Support for static scoping. Reading it from top to bottom, it's return address, static link, dynamic link, parameters, local variables. Nested subprogram, static chain, static depth, chain offset. Difference between static depth of procedure containing the reference to the variable x and static depth procedure containing the declaration of x. Static depth is the integer associated with static scope that indicates how deeply it is nested in the outermost scope. Static chain links all static ancestors of an executing subprogram. Drawbacks of nested subprograms. A non-local reference is slow if the number of scopes between the reference and the declaration of the reference variable is large. The time-critical code is difficult because the cost of the non-local reference are hard to estimate. Display. Alternative to static chains. Oh, my music's getting a little loud. More displays. Alternative to static chains. Store static links in a single array called a display instead of storing in the activation records. Address to non-local requires exactly 2 steps for every access, regardless of the number of scope levels. Static scoping. A static chain is a chain that statically links is a static links that connects certain activation record instance. The static link in an activation record instance for a subprogram A points to the activation record of instance of a static parent. The static chain from an activation record instance connects to all of its static ancestors. Static depth is an integer associated with a static scope, whose value is the depth of nesting of that scope. Block. A block are user-specified local scopes for variables. The lifetime of temp in the above example begins when the control enters the block. The advantages of using a local variable like temp is that it cannot interfere with any other variable with the same name. Block. User-specified local scopes for variables. Block can be implemented using a static chain. Block are treated as parameterless subprograms that are always called from the same place in the program. Every block has an activation record. An instance is created every time a block is executed. And alternative is the amount of space can be allocated statically. We're done with chapter 10. Let's move up to chapter 11. 19 slides. Let's get it. Review ADT and encapsulation. What I remember from encapsulation, a capsule is a closed container, and to encapsulate means to close things up and put them together, from what I remember. And in this chapter, we'll be doing Steve Add's motivation and history of abstraction, the concept of abstraction, data abstraction, encapsulation constructs, naming encapsulations. Motivation of abstraction. Work done by 2 months by one software is more than work done by 1 month by two software engineers. Adding software engineers to a late project will only make it later. Why? Because you gotta remind everybody about and catch everyone up to speed, and that takes time and cost. Separation of concerns. Modules managing naming space, public and private, that's accessible inside the module and outside the module. Modularity. It's just the 3 goals of modularity are decomposition, composability, and abstraction, which is the problems to this, which on top to bottom, what I just said is the problem to subproblems combined to the solution, capability of understanding. Abstraction, paradigms, which are top-down, functional, design models, UML, and programming languages, C, C++, Java. People think and learn in abstraction. It provides a robust set of abstractions, allowing models to occur close to the real world. Abstract data types, ADT, identifies kinds or types of information, encapsulates information, and provides a public interface of methods. Hide information and method codes in private implementation. ADT design guidelines. Cohesion. Well-defined components perform a single task of single objectives. Coupling. Components interaction are known and minimal. Uh, Benefits of abstract data types: support for reusable software components, creation and testing and isolation, integration of working components, view problems at a higher level. It's a public interface that limits access to data, and private implementation is unavailable. Inheritance and multiple instances to the same class are benefits. More advantages of abstract data types: abstraction is promoted and achieved. Concurrent engineering is feasible. Reuse and evolution are attainable. Emphasizes static system behavior. Drawbacks: without inheritance, redundancies likely occur. Dynamic systems behaviors. Dynamic system behavior is still difficult. Associated between Associations between abstract data types are difficult. Only inclusion association supported. Parameterized abstract data types allow designing an abstract data type that can store any type of element. Only issues for statically typed languages. Generics parameterized abstract data types. Develop a classic programming problem is develop a stack to a single type. What do generics offer? A type parameterizable class, abstract linear or abstract similar behavioral into a common interface, reusable and consistent classes. Benefits of generics: strong promotion of reuse, develop once, use often, stack and set examples. Simplifies maintenance problems, focuses on abstraction and design. Once designed and developed, reused if problems, corrections in a single location. Abstract classes and methods. Abstract classes cannot be instantiated, can only be subclass. Keyword abstract before keyword class is used to define an abstract class. Abstract methods. Class may contain abstract methods. This allows an abstract class to provide all the subclasses with a method declaration for all methods. Nested subprograms. Organizing programs by nesting subprogram definitions inside the larger subprogram that uses them. Nested subprograms are supported in Python, JavaScript, and Ruby. Naming encapsulations. Large programs define many global names. Need a way to divide into logical groupings. A naming encapsulation is used to create a new scope for names. C++ name scopes or namespaces. This small information doesn't matter. We're done with chapter 11. Two more chapters to go, and we'll be done, boys. Yeah, we're at 12 now. 50 slides are left. So review object oriented. Object oriented programming, also known as OOP, supports procedural and data oriented programming. Some support functional programming. Newer languages do not support other paradigms but use their imperative structures. Some are pure OOP. Object oriented programming, three major features: abstract data types, inheritance, and polymorphism. Inheritance, productivity increased through reusing. Inheritance is just inheriting from another class. Object oriented concepts. Um, Abstract data types are usually called classes. Classes instances are called objects, and a class that inherits is a derived class or a subclass. The parent class is a superclass, and subprograms are methods. Call to methods are called messages. The entire collection of a message is the protocol, or a method is the message protocol. Messages have two parts: a method name and the destination object. Inheritance can be complicated by access of control to encapsulated entities. Besides inheriting methods as is, a class can modify an inherit method. This is called overriding. Object-oriented concepts continue. Three ways a class can differ from a parent. The subclass can add variables and or methods to those inherited from the parent. The subclass can modify the behavioral of one or more of its inherited methods. The parent class can define some of its variables or methods to have private access, which means they will not be visible in the subclass. There are two types of variables in this class. Class variables, which is one class, inheritance instance variables, which is one object. There are two types of methods in a class. A class method, accepted messages to a class. Instance methods, accepted messages to objects. Single versus multiple inheritance. One disadvantage of inheritance for reuse creates interdependencies among classes that are complicated to maintenance. Dynamic binding. A polymorphic variable can be defined in a class that is able to reference or point to an object of the class and object of any of its descendants. When a class hierarchy includes classes that are override methods, such as methods call through a polymorphic variable, the binding to the correct method will be dynamic. Allow software systems to be more easily extended. Dynamic binding concepts. An abstract method is one that does not include a definition. It only includes a protocol. An abstract class is one that includes at least one virtual method. Design issues for OOP. The inclusivity of objects are classes, subclasses, subtypes, single versus multiple inheritance, initialization of objects, nested objects, the exclusivity of objects. Everything is an object. Advantage, elegance and purity. Disadvantage, slow operations on simple objects. Add objects to complete a typing system. Advantage, fast operations on a simple object. Disadvantage, results in confusing type systems. Include an imperative style typing for primitives, but makes everything else objects. Advantages, fast operations on a simple object and relatively small typing systems. Disadvantage, still some confusion between the two type systems. Are subclasses subtypes? Does a is a relationship hold? If a derived class is a parent class, then the object of the derived class must behave the same as the parent class. The derived class is a subtype if it has an is a relationship with its parent. Subclasses inherit implementation. Subclasses inherit interface and behavior. Multiple inheritance allows a new class to inherit from two or more classes. Disadvantages of multiple inheritance: implementation complexity due to a name collision and potential inefficiency. Cost too much. Advantages: sometimes it's quite convenient and valuable. Allocation and deallocation of objects. From where are objects allocated? If they behave line the if they behave in the abstract data type, they are allocated from anywhere. If they are heap dynamic, references can be uniform through a pointer or a reference variable. If an object are stacked dynamic, there is a problem with regards to subtypes, object splicing. Dynamic and static binding. Should all binding to a message to methods be dynamic? If none, you lose the advantage of dynamic binding. If all, it is insufficient. Maybe the design should allow the user to specify. If a new class is needed by one class, there is no reason to define so it can be seen by other classes. Other issues, which facilitates of the nesting class should be visible to the nested class and vice versa. Initialization of objects. Are objects initialized to values when they are created? Implicit or explicit initialization. Instance data storage. Class instance records, CIRs, store the state of an object. Static built at the compile time. If the class has a parent, the subclass instance are added to the parent CIR. But the CIR is static. Access to all instance variables is done as records. Efficient. Dynamic binding of method calls. Methods in a class that are statically bound need not to be involved in the CIR. Reflection. Programming language that supports reflection allow programs to have runtime access to their types and the structures to be able to dynamically modify their behavior. The type and structure of a program is called the metadata. The process of a program examining its metadata is called introspection. Interceding in the execution of a program is called intercession. Use of reflection in software tools. Class browsers need to enumerate the classes of the program. Visual IDEs use type information to assist the developer in building the correct type. Debuggers need to examine private fields. Test systems need to know all the methods in the class. Downside of reflection. Performance cause, expose private fields, and may not run under security manager, making code not portable. Alright, the last one, boys and gals. Reviewing concurrency and tasks. This is talking about ADA support for concurrency, Java threads, C++ threads, concurrency in functional language, and statement level concurrency. Introduction to a subprogram level concurrency. A task or process or a thread is a program unit that can be in a concurrent execution with other program units. So yeah, what I know about a thread is just a path of execution in a program. Task differs from ordinary subprograms in that a task may be implicitly started. When the program unit starts the execution of the task, it is not necessarily suspended. When the task execution is completed, control may not return to the caller. Tasks usually work together. Two general categories of tasks. Heavyweight tasks executes in their own address space. Lightweight tasks all run in the same address space, more efficient. The task is disjoint if it does not communicate or affect the execution of any other task in the program in any other way. ADA support for concurrency. It has a message passing model. The task body. The body task describes the actions that take place when the rendezvous occurs. The task that sends a message is suspended while waiting for the message to be accepted and during the rendezvous. Tasking in ADA. Declared a task type. Termination of task. The task terminates when it reaches the end of the begin-end code of its body. Tasks may either be very static or very dynamic. Statement delays. Delay statements temporarily pause the task. ADA tasking examples. A task body specification, the task body, the task that is the declare type. Yeah, I'm not going through the examples. Statement level concurrency, objective, provide a mechanism that the programmer can use to inform compilers of ways it can map the program onto the multi-processor architecture, minimizes communication among processors and memories of the other processors. Well, this completes my video. I hope you guys enjoy. I'm sorry if it was a little bit dry at some points, but I try to do my best. Alright, goodbye now.